Here are your solutions to the letter problems for Chapter 5, Lesson 2. Letter A asks us to refer to the diagram shown, and AR equals CR, so right here is AR equals CR, and furthermore DR, which is right here, equals BR. Then they want us to write a proof to show that AR plus DR equals CR plus BR. So, first of all, we need to recognize that we're given some information. We're given AR equals CR, so we can put that in here, AR equals CR. We are also given that DR equals BR, so we can place that here. Now the next thing they want us to do is label what we're going to prove, and that's given to us right here. We have CR plus BR on this side, that's right here, and we are going to try and prove that AR plus DR equals CR plus BR. So now it says, proof, you know that AR equals CR and DR equals BR. That was given up here. AR plus DR equals CR plus DR by the what property of equality? Well, let's take a look at this. We had AR equals CR, so we had AR equals CR, and that's where these two come from. So in order to move to this next statement, basically they're asking you what happened here. And as you can see, what we did is we took this one original statement, AR equals CR, and we changed it to AR plus DR equals CR plus DR. In other words, we added DR to both sides. So this would be the addition property of equality. And then lastly we have, so AR plus DR equals CR plus BR. Now notice that we've now suddenly changed DR here to BR here. And that is by what? And we can go back here and see that DR equals BR was given, and we can do this by substitution. Now let's take a look at letter B. The statements for a two-column proof to show that if the measure of angle Y equals the measure of angle Z, then X equals 100 are given below. Complete the proof by providing the reasons. So first of all, we have the measure of angle Y is equal to the measure of angle Z. Well, that's given right here. Then we have the measure of angle Y is 2x minus 90. That's given right here. And then we have the measure of angle Z equals x plus 10. That's given here. So our first answer here would be given. All this is given. Next, we have 2x minus 90 equals x plus 10. Now let's take a look at where that comes from. We have 2x minus 90, that was right here, equals x plus 10. And here is the explanation of that. If you remember that the measure of angles Y and Z are equal, well, they're both right here. So if these things are equal to each other, then these two things must be equal to each other. And that's how we can make this statement here. And that statement, we know that by substitution. Basically what we're doing is just substituting. Next we have step C, which says then x minus 90 equals 10. And we can take a look at that and recognize that what we did to both sides here, you can see that the x is missing over on this side, so clearly we subtracted x here, and we subtracted 1x here, and we get 2x minus x is 1x minus 90, and then this is a zero pair here, so it's gone, and we just have plus 10. So this is the subtraction property, I'm going to abbreviate this, subtraction property of equality. And then lastly, we're going to add 90 here to both sides of the equation. So this is going to be the addition property of equality. And that is our solution. Please do guided practice.
Okay, I'm doing this one with the answers turned on here. Like I said previously, I want you to understand that the biggest thing is we want to get you fairly skilled at doing these proofs. Use the figure to complete the paragraph proof. So we've got a measure of angle 1 and a measure of angle 2 equals the measure of angle 2. measure of angle 1 and 2 are supplementary. That's given. So 1 and 2 are equal and they're supplementary. So prove that angle 1 and 2 are right angles. So we have measure of angle 1 plus the measure of angle 2. Well, obviously it's 180 degrees, and that is because they're supplementary angles. Since angle 1 equals angle 2, then the measure of angle 1 plus the measure of angle 2, because we can substitute, we're going to substitute. So since 1 equals 2, we can substitute the second one in here for 2, because we were told that they're equal to each other. So we have measure of angle 1 plus the measure of angle 1 is 180 degrees. That's substitution. Solving that equation means that measure of angle 1, let's put that over here. We would have the measure of angle 1 plus the measure of angle 1 equals 180. Solving the equation gives measure of angle 1 equals 90 degrees. Since measure of angle 1 equals measure of angle 2, then the measure of angle 2 is also 90 degrees. So basically you would have 1 plus 1, in other words, 2 angles equals 109. 2 angles, angle 1 doubled, would equal 180. If we divide both sides by 2, we would have the measure of angle 1 equals 90 degrees. And since 1 and 2 are equal, then angle 2 is also 90 degrees. I know this gets a little bit complicated, but take some time and work through it, and you'll see that it's really fairly doable. Refer to the figure above. Complete the two-column proof to show that if EG equals 3x minus 1, ED equals 2x plus 4, and EG equals ED, then x equals 5. So basically what we're showing here is that EG and 3x minus 1 and ED equals 2x plus 4, but since EG and ED are the same, that would mean that this and this are also the same. Okay, so the first thing we're going to do is we're going to list those three things, and that of course would be given. Then we're going to do like I did up here, that since these, let's switch colors, since these two are the same and these two are the same, and lastly these two are the same, then that would mean that our very last thing here, this and this, I shouldn't say the same, I should say are equal. So that is by substitution that we can show that 3x minus 1 equals 2x plus 4. Now we've got 3x minus 1 equals 2x plus 4 here. Well, the reason we get to x minus 1 equals 4 is we're going to subtract 2x from both sides. Once we subtract 2x from both sides, we have 3x minus 2x is x, minus 1 equals, we have a 0 pair here, equals 4. So we can see that that was the subtraction property because we subtracted the same amount from both sides, the subtraction property of equality. Then lastly, we're going to have the addition property of equality right here because we're going to add 1 to both sides, and we end up with x equals 5. You can see here where it's going to be very important that you know your rules of algebra so that you can see the algebra that was done in order to come up with these reasons here. Building on the essential question, how is deductive reasoning used in algebra and geometry proofs? A good way to put that would be you use facts, definitions, and properties in proofs. The whole idea is to be able to extend something you know to build it into additional things that you know and understand. Please do independent practice.